So, hi guys. We have a situation. So, one of our team member, Harshkumar Mangroliya, has tested COVID positive. So, he is not able to speak right now. So, he is here to present, but he will not going to explain anything. Thank you. So, Nikhil, start with the introduction part.
Okay. My name is Nikhil and my registration number is 19BCT0209. So, introduction about 8051 timer. 8051 microcontrollers have two timers or counters which work on the clock frequency. Timer or counter can be used for time delay generation, counting, extendables, and many more. The time register can be used in two modes, timer mode and counter mode. The only difference between these two modes is the source of the incrementing the time register.
So,
So you want to explain about project.
yeah. So, to execute the timer count, we first have to create a new project. So we'll go to the new project and we'll name it to timer and save. So and we have to here we have to select the device. So our preferred device will be 883S52. So it's here. So click on OK and then no. So you can see our project name timer and the target ones here. So first we have to create a new file and paste. We have the code in document, so we can paste it right here and save. So this is the for the timer zero. This will be the timer mode zero. So I'll save this file as mode zero.c because this program is in language C. So we have saved the file, but it's not shown in the target one. So what we are going to do is we going to add this file to our project. So our project, our file has been added to the. So now uh, to explain the code part and example, so Rajdeep going to do that. Over to Rajdeep. Examples.
Everyone, I am Savani Rajdeep. My registration number is 19BCT0100. So, uh, uh, in this tier, we have two mode of this timer, mode 0 and mode 1. And how the timer works. 885 has the two timers, timer 0 and timer 1. So we will call the timer 0 at T0 and the timer 1 as T1. Both are 16-bit vital. Since 8085 has a 8-bit architecture, each of these is accessed by two separated 8-bit register as in shown. This register are used to load the time counter. 8085 has a time mode register and time control register for selecting the mode of the operation and controlling purpose. This quick introduction for this timers. TMOD register. Basically, TMOD register is an 8-bit register used to set the timer mode of timer as timer 0 and timer 1. Its lower 4-bit are used for timer 0 and upper 4-bit are used for timer 1. After that, TCON register, TCEON register. It is basically 8-bit control register. It contains a timer and interrupt flags. Okay. After this, we are coming to this example of timer mode 0. Timer mode 0. Can you scroll a little bit up?
Zoom.
No. Yeah. Okay. So in this we have to generate 2 millisecond period using the 86851 microcontroller, which is in the software. with the timer 0 and mode 0 on the P1 0 pin of the port 1. Okay, so here we are here is the 2 millisecond time period. One is for upper bit, and means one is for higher, one millisecond is for lower. So as we getting the frequency of 11.052592 megahertz from this oscillator, and we have this machine cycle of 1.085 microsecond. So we have to require the count for the delay. So basically this is the machine cycle, and we have to generate the count for whole 1 millisecond of the for high. Okay, so we are getting the count as approximately 921. So basically 921 times this timer goes for high and for high and for low. Okay, so basically the maximum count of the mode is 2 raised to 26 because it is the 13-bit resistor. So this timer will goes only the forward direction, means incrementing direction. So we have to from the highest count we have to minus 928, which is that from we are minus 921 from 8191. So we can and we have to add the 13 machine cycles for the return to the delay function. So basically we are getting the value as 7284, and we are converting this values into hexadecimal value, which is 1C74. So 1C74 is so this is the binary value for 1C74, and we are loading this lower 5-bit into TL0 and higher 8-bit to the TL0. In this we are loading 5 bits only in the TL0, and other 3 bits of TL0 is basically 0. So this is the TL0, and this is the TH0, which is E3, and TL0 is 14. So coming to the code. Okay, then here yeah, we are setting this. We wrote this S bit test P10. Basically, S bit is the this keyword to mention that we are setting up the pin and the port, and here we are setting the pin 0 and port 1. Okay, after that we jump to the main function. Here the T mode time. Here we are using this T mode resistor. In this we are using timer 0, which is the first 0. It is for timer 0, and second 20 is for the mode of the operation. Here 00 is for 13-bit timer mode. Okay, then coming to the while loop, it is infinite loop basically. Then here we are toggling this test variable value. If it is 1, then it will be 0, and if it is 0, then it will be 1. After that, we will jump to the timer delay function. At the timer delay function, we are setting the values of that values of 8-bit and 5-bit. Okay. After that, there is a TR0, which is timer 0 run control bit. So as we set this bit as 1, so we can start the timer 0, and for while at the while loop, this is TF0, which is basically overflow flag. If it is 1, then it will be it is overflow occur, and if it is 0, then overflow is not occur. So basically here the while loop is running running from that running from that 7 running from that 7 to 8 4 position to the highest position as it is as it is touched to this highest position, means reach to the highest position, uh, it convert the TF0 flag to the 0 as it is. uh, so basically the timer is stuck in between this while loop while TF0 is 1. So as the TF0 is getting 1, it will be come out from the while loop and set the timer bit as 0, because now the operation time is over. So we are setting the TR0 bit as 0. So it means it has stopped this timer, and after that we are clearing that clearing of a flag, because if we use again this code, it will get the TF0 as 0. No, there is no overflow occurred already. So that's it. That's how we stop this program timer delay to the 1 millisecond. For upper, and again the code will run as the timer toggle, and again the timer delay function will call. It is run for the second time delay for 1 millisecond, but it is lower, and again it is running. Basically it runs until till 9 until it's an infinite loop. So basically it is running. So that's all. This is the code for that timer mode 0 operation.
So now we are going to see the output. So first we need to build this. So there is no error and no warning. So we'll go into the debug part in the peripheral. So let me wait. So in the peripherals, in the input output, we'll select the port 1, because we are setting test variable as the port 1. So we into port 1. So everything else we can set to the 0 except for the 0th bit. And now we'll run the program, so we can see that there is register is toggled. So this delay is 1 millisecond. So we can close this, stop the run, and we'll create the new file for the timer 1, timer mode 1. So to do that, first we need to create the new file, and we have the code for the timer mode 1. So we'll just copy it and paste it there, and save the program as mode 1.c. I'm going to close. But as you can see, this is not coming in the target one. So we can include that file with mode 1 in the add, close. And we need to remove this file. So now we can see that it's here, and the explanation part of this will be in the Rajdeep. So over to Rajdeep.
So now we are on mode. We are for example for mode 1, timer mode 1. Okay. So as we did in mode 0, we have to generate a 2 millisecond wave. Time period wave, and it is also it is in 89C51 microcontroller, which is in that software. In this, it is in mode 1, pin 0 at port 1. Okay. So in this example, also we have to generate this 1 bit higher, 1 millisecond for high and 1 millisecond for low. So we are getting the count is 921, which is same as previous one. Okay, but in this main difference of this mode 0 and mode 1, it is 16-bit register, and mode 0 it is for 13-bit register. So so in this maximum count is 2 raised to 16 bit, because obviously it is 16-bit register. So we are this is only for forward direction, as we mentioned previous one. So we have to shift our register to the back side of this maximum count, and as we start the counter, it will go to the forward direction. Okay, and extra 13 machine cycles we have to add for this delay function. Okay, as we are getting 64,651, and we have to convert it as in hexadecimal FC74. So we have we are dividing this mode 1 in 8-bit register for low and 8-bit for high bit. So we are allotting this value FC to the TL0 and 74 for the TH0. Oh, sorry. TH0 has the value FC. TL0 has the value 75, which is lower bit. So come up to the code. Okay. So as we did it previous one, same as it as bit is for setting this test variable values. That is pin 0 at port 1. Okay. After that, we are jump to the main function. Here also we are using T mode. This 0 is for timer 0, and 01 is for mode. It is 16-bit register mode. Okay. So we are in this while loop, we are toggling this test value as we did in previous one, and after that we are jumping to the timer delay function. At this we are load this value TH0 and TL0 registers. Again we are starting this TR0, means start the timer. We are starting the timer, and coming to the while loop, it is overflow flag, and we are setting as we are checking at here if the timer bit overflow flag is 0, then again and again it is checking this overflow flag condition. As it is as the overflow flag is 0, it will come out from the while loop and set up and stop the timer, and and change the value of that overflow flag to the 0 again. So as it is, it will run the code, and we can get this timer delay for the 1 second for 1 millisecond lower and for 1 millisecond higher. That's all.
So for the mode 1 outputs, so first of all, we build our program. So there is, you can see there is no error and 0 warning. And we go to the debug part. Wait for a second. So after this, in the parentheses, we go to the port 1, because here we are defining our test variable to port 1's 0 pin. So only 0 pin will be 1, except all the 7 pins will set to 0, and then we'll run the program. So you can see that it's toggling, and toggle value is the 1 millisecond. Every 1 millisecond, it's run again and wait for the another 1 millisecond. So here is the how timer works. Thank you.